Hey guys, how's it going? Bob from Bobots Trains and Maker Zone. I've had my 3D Walks 3D printer for a couple months now. Been playing with it for a little bit. And I thought it would be a good time to follow up and do another tips and tricks number 2 so that we can basically share some information among some of the buyers. I've seen some more people buying these things now, so let's get started. Let's start out with a simple tip that I really didn't know for a little bit, and that is that the 3D Walks desktop software can load and send G-code directly to the printer over the network. That's right. So my workflow is Fusion 360 or maybe 123D design, and I go in and export an STL file when I'm done, put it into Simplify 3D and slice it, and then I was copying the G-code onto a flash drive and sneaker netting it over to my printer. Well, since my 3D Walks is hooked up to my network with an IP address, all I need to do now is load the G-code with the menu you see here up in the upper left, File, Load G-code, and that'll take the G-code directly that comes out of Simplify 3D, and then you just hit the print button over on the far right, and it will send the job through the network over to the printer. So no need to carry a flash drive over there anymore. Now you don't get a preview and you don't get an estimated time or materials used, but you can see that stuff in Simplify 3D, and it does save me some time and effort, and it's easier to do this way. So a good tip. I didn't know it for a while, but I'm glad I figured it out. One of the reasons I bought the Sindoh 3D Walks was because it had this removable build plate. So the heated bed is underneath, and then on top is this Teflon coated aluminum plate with these little clips, and you push down these little clips and you can pull this out and scrape off your project without throwing your bed out of alignment. Don't overlook these screws in here. There's 4 screws, and they will come loose over time. So pull this gray clip away from the build plate, both of these gray clips up and away, and then tighten these screws, and that'll give you more tension for the problem that I'm going to discuss here in a second, which is I've always had problems with different build plates in this machine with the Y-axis. When you clip this thing in, there's always play back there in the back. You know, it's not machined 100% perfect. I'm going to show you what I did to fix it. Now we're talking about the play in the Y-axis due to the heated build plate and the Teflon coated aluminum plate clips not holding so tight. There's always some play in that, which will give you some layer shifting in your print. Now what they recommend is taking a very thin piece of foam. And I can't get it to set up on edge because I'm working around the camera here. I'm not laying down the way I'm doing it, but vertically up like this, and then get it down in there and sandwich it in there. When you tighten it up and clip it in, it will work for 1 or 2 prints. The problem I've seen is all the build plates aren't exactly, the same here, and over time, just because of the heat on the edge and the thinness of this and squishing it in there, over 2 or 3 prints, this stuff sort of disintegrates or breaks down, and it doesn't give you as much resistance. So this is what I've done. I'm not recommending it. I'm just telling you what I did. This is a new build plate that I got, and I thought I want to be able to exchange plates and not have a problem. So I don't know if you can see this on the camera, but let's see. You might be able to see it. There's about 3 spots here, and here. Whoops, and here. That the metal is slightly bent in, okay? I took these Craftsman vice grips. They have a nice flat square edge on them. They're not like regular vice grips. And I tried, needle nose pliers and other pliers. They didn't work. So again, I'm not going to recommend it, and I can't get in here to show you, but I set them down on here and I tightened them. And then they were sitting like this, and I just went and pulled just a little. I had to get them flat down because I don't want to bend this whole back plate up. I just want to bend that back flange in, like here, like 3 spots. And the point is, when I'm done, what that does is when I clip this thing in, see now there's 3 little spots are pushing just enough that this thing it's going to have some play in it now. But look, the whole thing's moving. I don't have it powered on, so the belts are moving. But at least the build plate is not moving at all from the heated plate underneath it now. So that's what I'm going to try. It didn't damage anything. It just made things better. And it seems like it may help with the one thing out of this beautiful printer, this awesome printer, that I think could be a fatal flaw, because you get a lot of y-axis movement, layer shifting in your prints. But I love the fact that this build plate can come out of here so that I can scrape the prints off without throwing my, my bed out of level. I want to show you my old build plate and how I ruined it. But I do have a couple recommendations actually. In my previous video, I was suggesting using a scraper like this, a paint scraper, and it's just a blade, razor blade in there to get your prints off. And I still use that, okay? Because especially ABS on here, it adheres really well. These little marks that are left on here, any PLA prints did not leave marks, but the ABS always leaves marks on here. Regardless of PLA or ABS, I can't easily get the prints off with this. I would end up damaging the corner of the print. I can't get under it. And what I was doing arbitrarily was using this. Now the problem was, well, there's two problems why this happened. But I know one thing, I was coming in too much of an angle. You know, and there's a chance, what I should do is grind off the corners of these blades so that they're more like this. If you have a way to do that, that's what you want. Because you have a tendency, this edge could this is just a Teflon coating here. So the edge of this blade could cut into your mat, okay, your Teflon. So the first thing is, I'm still doing it that way on my new bed, but the angle should be very shallow, just so that the metal touches. Don't come in like this, come in and just so that it touches, that you can get under there. Don't push hard into it, just slide it under, get the edge, work it. Once I do that, and sort of just get the corner of the print opened, then I come in like this. Now this is a build tack spatula. By the way, they couldn't sharpen this any sharper here, which would have been awesome, but then it would have been considered a blade, you know, a weapon, so they can't do that. So I get the edge under here, and then I come in with this and get this under, and then I pull this out. Now I can just come in here and the print real slowly work my way and it goes, comes off. Now I'll talk about this. Yes, I did that, and that was probably over time. But I think the issue here, which is very critical to consider, I wanted to do an ABS print. I think they suggested 90 degrees Celsius for the heated bed. I bumped it up to 100 because I was having some issues. I don't think that in itself did it, but when you're doing ABS, your bed is hotter. When you get done, it's going to stay hotter for a longer period of time. I've had much better success with letting the bed cool down under 50, under 40 Celsius, even better. If you can let it go an hour or two, I'll print something overnight. I'll get up the next morning and I'll come in and use this, and it pops right off. So I had it real hot and it messed up and did something. And I thought, oh, I'm going to go in here and start over. And I scraped it off with this. So this was hot, and there's it's like a stickum under here, something. So it's aluminum bed with some kind of stickum in this plate. And I went in to do it, and it just I think the edge caught and it started peeling up. I did this. I mean, I just kept cutting it to straighten it out, and I ended up ruining this bed. They're $60. You can buy them on Amazon. I replaced it. I actually think this bed was slightly warped from the factory because I have much better leveling on the other one now and much better prints. So don't ruin your bed. That's just a little hint, you know. Leave it cool down, come in at a shallow angle, get under the edge, use something like this. This may work. I got this for $4 or $5. These are very flexible, you know, on Amazon. Don't bend this. Apparently people have complained once you get under there one time and bend it, it's done. This is what they sent me with the Sindoh, and it works good too. So just some hints there. Just some generic information on ABS. Some things you want to print ABS, like this door stop, because you want it to be more sturdy. You don't want it as brittle as PLA. Or this, you know, solder wire holder because of the heat. You know, there might be some solder in it. ABS is more resilient to heat. But the one thing is I get beautiful prints off this machine in PLA. The ABS, I do have a few challenges, but when I went to do this thing, which is a grocery bag holder, I overdid it, and it came out really solid, okay? But I wanted to make sure it didn't break back there on the right-hand side at, the obvious breaking point. So I did things like I printed an ABS, and because it was so thick and heavy, I bumped up my extruder and my bed temperature 5 or 10 degrees on each one. You'll probably want to put a brim around it, maybe a 3mm brim, maybe more. But I did like a lot of shells. Not excessive amount, but I did a decent amount of shells, outer shells. And I think doing that, and I did a heavy infill, like maybe a 40% infill, 45% infill. And on top of that, then I did a solid layer every 20 layers or something like that. Point is, I think the edge of it, you can't really see it here, but the bottom left edge of it started peeling up from the bed at some point. And, I think with ABS, because of the cooling effect and everything like that, you get too much. If you make it too solid with too many shells and too much infill, it's just going to cool and pull away from the bed. So just some challenges. I mean, in general, if you can do it, go with the PLA. I've had much better experience with it. I mean, just in general, the PLA is more brittle, but it'll give you smoother prints. It has less or no warping, really. But the problem, and there's no smell, but the problem with it is it's just not as strong, and it's just not temperature resistant. So if you're going to do something for in your vehicle in the hot temperature, I guess you want to use ABS. This machine will do both. I just have better success overall with PLA, so I go to that first if I can. Talk about this real quick. This was a test lead wire holder that I created, and I used PLA material. But the difference here is I bumped the speed up on this to 60 millimeters per second instead of the suggested 40 millimeters per second when I printed it. And that was just showing underneath there. I had a bridge and I didn't use supports, but it's structurally sound. So anyway, look at the quality of it. I mean, it's good. And this is, 60 millimeter per second printing instead of the 40 millimeter. So I had no adverse effects of doing that. It just printed faster. So I may experiment with that some more in the future to save time. I do want to mention, you see here where it says version, Rodin 16.05.05. That's the newest firmware that I found available as of July 2016. I just installed it. I've been getting beautiful prints on the 3.3 firmware. And I think they just number their firmware like 16.05.05, which is May 5th. 16.03.03 was March 3rd. So if any of you guys know what the changes are from 3.3 to 5.5, or if Sindoh reads this, or if I find out from them, because I have written to them and asked them, we'll post it. Somebody please post it below this video what we can expect for the firmware changes. I was getting beautiful prints, as I said, on 3.3, so I hope I didn't mess anything up by changing to this, but I really like to keep the current firmware on all my devices. So I really like the 3D Woks. I hope we all continue to have great success with it. And I really look forward to when they come out, hopefully shortly, with this ability to use generic filaments. And they provide you a chip and a cartridge for it. So I hope this has been informative to you, and thanks for watching.